Well, hello and welcome to another DevNation Live Tech Talk. We're coming to you live on Thursdays like we do every Thursday at noon Eastern Standard Time. And we're going to have a lot of fun today. We're going to talk about Quarkus and how it matches up with another interesting topic. It's an endless interesting topic. And we have a great person here today with us, Ioannis. He's going to show us how to make this stuff work. He's the magic man who doesn't make it work. And remind you guys, we do a ton of DevNation content, telling your friends and neighbors, hundreds of other industry courses, and interesting events. Be large audiences. Let's ask questions. I'll show you different cool demos, different techniques, and we want you here. So if you have any feedback at all, you have my email address. You will receive an email from me every Thursday morning, where you can then respond and say, "Oh, I'm interested in this topic. You do this or that." Feel free to give your feedback. I get a lot of feedback. Even if it's something wrong, I want to know so we can fix it. At this point, though, I want to turn it over to Ioannis, who's going to do the topic of Quarkus and Kubernetes. Ioannis, over to you.
Give me a second to share my screen there.
Yeah.
Hello, everyone. Bear, thank you for having me. Today, I'm going to talk about Quarkus and Kubernetes, and more specifically on how the whole developer joy spirit of Quarkus translates to Kubernetes. I will be sharing my experiences as one of the core Quarkus Kubernetes contributors, and as a person that has devoted a significant amount of time in making Java developers' life easier on Kubernetes. Today, I will start by telling a few things about which I think are the main factors that contribute to Quarkus awesomeness, and then I'll try to enumerate the steps that one needs to take in order to get a traditional Java application run on Kubernetes. While I'm at it, I will be demonstrating different extensions provided by Quarkus that contribute to the overall experience. So first thing first, what exactly are the factors that make Quarkus so fun to work with? My personal opinion is that it's all about consistency and developer friendliness. Now, Quarkus provides a concise bundle of frameworks and APIs and tools that fit perfectly with each other. They all have a single configuration interface, which adds to the consistency of things. And of course, it has the developer mode, which provides an amazing developer experience. The developer mode creates a continuous feedback loop where the developer is able to hack code and see that code take immediate effect in the browser without having to perform rebuilds, redeployments, and things like that. This is an amazing feature for newcomers because it allows new Quarkus users to easily pick up on how Quarkus thinks, how Quarkus works, what doesn't. And even for more seasoned Quarkus users, it allows them to familiarize with new frameworks, tools, and technologies that are part of the wider Quarkus ecosystem. Most importantly, it immensely boosts productivity for the apparent reasons. Now, we have consistency and user-friendliness being the core elements that we wish to capture and transfer over to Kubernetes. Now, before I move forward, I would like to create a simple Hello World application at this point, which is something that we are going to use throughout the whole presentation, and maybe also to give you a quick glimpse of how the developer mode looks like. Now, I switch to my editor, and I will start by creating a Hello World application using the Quarkus Maven plugin. The app is ready. I can CD into the application. And to show you how the app looks like, I will open the main source file, the Hello Java, which is a typical JAX-RS Hello World app. I can build this application using MVN and start the Quarkus dev mode. It should take just a couple of seconds in order to compile, run the tests, and then actually start the dev mode, which I should be able to access using my browser. So if I go to localhost 8080 plus hello, I should be able to see the response. I hope the font size is fine. Now, most Quarkus-related demonstrations at this point go to the message and modify it and make it something like hello from DevNation, and then refresh the browser in order to demonstrate how the change takes immediate effect, which is really awesome, right? Now, I won't be spending more time on the dev mode itself, as I want to focus more on the Quarkus side of things. So, what does it take in order to take a Hello World application like the one just created and deploy it to Kubernetes? Step number 1, I need to create a container image for my application. Step number 2, I need to make that image available in a container image registry like Docker Hub or even a private registry. Then I will have to create some ugly JSON or YAML blobs that will act as deployment descriptors. And finally, I would have to apply those manifests to a running cluster in order to deploy my application. Let's focus on the first step, which is the container image creation. In most cases, people use tools like Docker in order to create container images, but there are other options out there like Jib, Podman, Builda, Kanellos, or S2i for OpenShift users. What I intend to do is to demonstrate the provided container image extensions by Quarkus, which are a container image extension for Docker, Jib, and S2i. I'll start by demonstrating how one can use the container image Docker extension in order to build and push images to a registry, and how to perform various customization, as specifying different registries, providing authentication configuration, and stuff like that. Now, the first thing that one needs to do is to open the pom.xml and add a dependency that corresponds to the extension. And in my case, all I need to do is add the container image Docker extension. I won't be needing the dev mode at the moment. And what that extension offers me is the ability to trigger container image builds as part of my Maven build. So, for example, I can specify that I want a container image build by passing the flag Quarkus container image build if it's true. And while the application will run, I will also get a Docker build. I had a failure in my test, which is normal because I modified earlier the message that the hello method was returning, and I didn't have a chance to align the test. So let me align the test right now, once and for all, and try to recreate the container image again. Now, this time we can see that an actual Docker build has been triggered and is now complete. Now, if I don't want to specify that option every single time I perform a Maven build, I can pass this configuration directly to my application.properties. There we are. And by doing so, each time I perform a build, I will automatically get a container image build too. Remember, the application.properties is the file where we configure all things Quarkus. So I can configure everything from here, and I can do more things with the container image extension. I can specify that I want, instead of a build, a push each time I perform a build, or I can specify things like a registry, a username, oops, and the factors. Now it's time I perform a build. I will automatically have the image build and post to docker.io. It's worth mentioning that I don't have to specify the credentials here. If I'm using a docker config.json file in my home directory containing the credentials, all container image extensions can pick up the credentials from there. So I can just remove them. I just added there, to show you that I have that option. The image should be pushed by now. And let me verify that. Let me refresh the screen. I opened my Docker Hub page and I can see that the image has been pushed to Docker Hub like a minute or so. Well, one additional benefit of using container image extensions is that these extensions are interchangeable. So I started by using the container image Docker extension, and I can swap to using Jib instead of Docker without having to perform any other change. No changes in plugins, no need to reconfigure anything, just swap Docker with Jib. By performing a build, I'll see that I will get a Jib build instead of a Docker build. You may be wondering why use Jib instead of a Docker. I can think of two reasons. Reason number one is that Jib allows for Dockerless builds, which means that one can use Jib and create container images without having a Docker daemon running locally or having any sort of Docker installation. Another reason is that Jib is very good at handling the image layers, which result in performing builds faster and things like that. I managed to achieve the same thing, build a container image using both Docker and Jib, and I think that at this point I should move forward with deployment. Let me move back to my slides. Okay. The next thing that I need is the creation of Kubernetes manifests. For that purpose, I can use the Quarkus Kubernetes extension that can generate the manifest for me. Now, this manifest contains information like the Docker image that we're going to use, how we can run that Docker image, information related to the environment, like variables, volumes, and mounts that I may want my application to use. And all these are information that the Quarkus Kubernetes extension can obtain from the Quarkus build system. So through the Quarkus build system, it has the ability to obtain user configuration, but also to retrieve information provided by other Quarkus extensions. So for example, if anyone changes the port name, the Quarkus Kubernetes extension will be able to pick it up from there. If anyone adds extensions that provide information like health endpoints or integration with metric systems and stuff like that, the Quarkus Kubernetes extension will be able to pick it up and create the best possible manifest that fit the needs of our application. Again, in order to use that extension, I will have to go to my pam.xml and add another dependency. This time it will be the Quarkus Kubernetes manifest. I would also like to jump back to my application.properties and remove the push so that I don't have to push every time. And now that I'm going to repackage my application, I expect to find under the folder target Kubernetes generated manifests for deploying to Kubernetes. The folder is target Kubernetes, and I have two files. One is the Kubernetes JSON, and the other is the Kubernetes YAML. Both files contain the same information, one expressed in JSON and the other expressed in YAML. A simple file that contains a handful of Kubernetes resources like service accounts, service deployments, and things like that. At this point, I'd like to focus on the image, which in our case is docker.io/io Kanellos hello world, and is exactly what we configured in the application .properties as a container image. We specified that we need to use docker.io, and we get that piece of information here. So what I wanted to show you is how the Quarkus Kubernetes extension interacts with the container image extension. And if, for example, I move back to my application.properties and change Quarkus.io to pay.io, I expect to see that change take effect in the generated manifests. So that it's visible by changing the radius, I automatically get the generated manifest align my change. I can perform all sorts of configuration and customization through the application.properties. And at this point, I would like to start by adding some custom labels. I will add the label foo bar. And let's see how that affects the generated manifest. Here it is. We have foo bar in the manifest. In the same spirit, I can add things like notations. Or even stuff like environment variables. Now, the environment variables are a little bit different as they are slightly different in nature. Now, labels and annotations are plain key-value pairs, but for environment variables in Kubernetes, we may have references to feeds, we may have references to secret properties, config map properties, etc. So when we need to specify environment variables, we also need to define what exactly is our intention. In this case, a key value pair. And move to my container and wait until the environment variable is added. There we go. And I would like to add one additional environment variable, this time using a mapping to a secret. I will cheat a little bit and make use of my cheat sheet. Okay. Now, let me elaborate. By adding these properties, we are letting the Quarkus Kubernetes know that we want to add an additional environment variable called dbPassword that will point to the database password key of the database password secret. Now, in the same spirit, I can add all sorts of configurations, including configuration of volumes, mounts, even init containers, sidecars, and stuff like that. Now, there are people that will appreciate being able to configure everything using the standard Quarkus configuration mechanism, but there are others that would like to have the freedom to bring in their own resources. For example, someone may want to bring in his own secret or his own config map, or even his own deployment, right? And may wish to provide an initial template for that deployment, but have the Quarkus Kubernetes extension do all its magic and enrich it, decorate it with all the information obtained from the build system, like the ports, like probes and things like that, the image, anything. So what we added is the ability to provide your own resources that the Kubernetes extension will pick up. You can do that by adding a kubernetes.yaml file under src main Kubernetes. And at this point, I will try to demonstrate it. Now, what I'm going to do is that I'll copy and paste the generated manifest, not the whole manifest, but just the deployment. And I will add it under src main Kubernetes YAML. And let me optimize it. And I will remove all the things that I don't need, or all the things that I prefer Quarkus Kubernetes to filter me. So things like ports, service accounts, still policies, values, even environment variables. So I will remove one here, but leave the others. I'll set a custom number of replicas, and maybe even add a custom annotation. Now, the intention is to have Quarkus Kubernetes use the deployment that I just hacked as a starting point and start building on top of it. I will keep on the top the bring your own deployment, and I will have the result on the bottom. And also on the top, I intend to keep the configuration properties. Now, I will remove all the configuration that is now provided by the provided deployment, and we'll just keep things like labels and stuff like that. By saving, I will combine whatever lives on the top windows of my screen, and the end result is expected to be on the generated manifest that lives on the bottom of my screen. Example. For example, I expect to find the custom labels, the custom annotations, and for the deployment, I also expect to find the annotation that was provided by the initial deployment. And I also expect to find a combination of the environment variables that were specified in the initial deployment manifest. Cool. Now, if I switch back to my pom.xml and add additional extensions, like for example, by adding the small I shelf extension, and performing a simple MVN package, I expect to find the liveness probes, right, in the combined deployment. So what I did was that I brought my own deployment configuration, my own deployment resource, let's say. I customized it through application properties, and also I customized it through the Quarkus build system. How? By adding the small I extension that provides health endpoints. The Quarkus Kubernetes extension figured out that it would be a good idea if it added in the combined deployment liveness probes and things like that. I hope that I didn't make that too confusing. I've covered those parts. Now, the next step is deployment. I want to deploy the manifest that I just generated. I will be using MiniCube as a target cluster for development, which is one of the most popular options out there. Other options for development are the use of kind, microcaches, but MiniCube, I think, is still one of the most popular. Most users, when using MiniCube, tend to adopt some practices that further improve the user experience and the whole development process. And such practices are changing the service type to node port so that they can easily access the application through the node, or modifying the image pool policy and setting that to if node present, so that we don't have to pull the image every single time we perform a change. Now, the Quarkus team, in order to further improve the user experience, created a Quarkus MiniCube extension that aims to provide all those common patterns and common techniques straight out of the box to people that are using MiniCube. The extension can be used again using the pom.xml, so I can jump here and replace a Kubernetes with MiniCube. Before I do that, I would like to get rid of the Kubernetes resources that we manually created. Okay. And we can switch back to my cell and perform an npm package. But this time, I will also specify the Quarkus Kubernetes deploy back to true. What will happen is that we will get the resources generated, the regular Docker build created, and the resources will be applied to our local MiniCube. In theory, I should start seeing some pods right now. Wait, and I could access the service that we just deployed it by using MiniCube service list and just pointing to that URL. Great. So if I visit the hello endpoint, I get the hello from DevNation, which is the message that we specified earlier. I can very fast perform changes. So, for example, I can change the hello from DevNation to hello from MiniCube and do a very quick build and redeployment. This time, I won't have to push because I'm using the MiniCube extension. And when using the MiniCube extension, I'm sharing the Docker environment, so there is absolutely no need to push. And the application, the updated application has been deployed, and it should be up and running now. Well, yeah, perfect. Let me get back to the slides. Okay. We covered container image building and pushing. We covered Kubernetes manifest generation. I showed you some conveniency tools that Quarkus provides in order to, to have fun with MiniCube. Next step in this presentation is OpenShift. OpenShift is a Kubernetes distribution supported and provided by Red Hat, which provides some additional features on top of what vanilla Kubernetes provides. To name a few, I think it's the sexy web console that it provides, tools like S2i for performing in-cluster container builds, deployment config, which is, let's say, an enhanced version of the traditional deployment resource is available in Kubernetes. And deployment configs are able to integrate nicely with S2i and specify things like deployment triggers and stuff like that. And of course, we have an extension for it. I can jump back to my pampa.xml. At this point, I would like to comment out Docker because I will be using S2i. And instead of MiniCube, switch to the Quarkus OpenShift extension. Now, a few words about OpenShift and container image extensions. Currently, and by currently I mean in 1.6 release, which was released last week, if I recall, it was only possible to use OpenShift, Quarkus OpenShift, with S2i. So it was not possible, for example, to combine OpenShift with Jib or OpenShift with Docker. This is something that will change in the future releases, but at the moment, it is what it is, and that's why I'll demonstrate OpenShift with S2i. Before I try to deploy anything on a MiniCube, let me switch to an OpenShift cluster. Now, I logged in a remote OpenShift environment so that I can demonstrate the parts that are specific to OpenShift. And I will create a new project that I'll call Ioannis. And it might be a good idea to also modify the hello message and switch from hello OpenShift, hello MiniCube to hello OpenShift. Right? Now I'll rebuild my application, use the exact same setup, and this time I expect the app to get deployed to OpenShift. Now, what is going on? We compiled the application, packaged the application, we generated all the required OpenShift manifest, and now what we are seeing in our screens is an S2i build taking place. The S2i build makes use of a couple of OpenShift-specific resources like image streams and build configs. And the whole concept is that we make use of let's say, input image stream that plays the role of the from image. We define an output image stream, which will contain the result of the actual container image build. And we also specify an additional resource called build config that describes how we will combine the from image, the jar that we just compiled and built, in order to generate the output image. So that's called S2i binary build, and in essence, it's the process I just described. While we are waiting for the S2i build to finish, it might be a good idea to jump back to my application.properties and say a few things. All configuration options that are available to Kubernetes are also available to OpenShift. So if I just switch from Quarkus Kubernetes to Quarkus OpenShift here, the labels and stuff will be added to OpenShift. And just to verify, if I open the target folder, target Kubernetes OpenShift, in order to see the generated OpenShift resources, I should be able, to see everything there. I need to save first. Okay, and there we are. We have our labels, we have our annotations, everything. And in the same spirit that I provided an initial deployment resource through SRC main Kubernetes, I could do the same for OpenShift. I could provide my image streams, my own build configuration, my own deployment configuration, and things like that. The build seems to be successful. Before I do anything else, I would like to show you how the deployment config looks like. And I would like to just focus on the bottom part, which is the trigger, which actually triggers a redeployment each time the specified image stream tag gets updated. Okay. Let's see what we have here. The application is up and running, and I can easily access the application by exposing it to the outside world using the OC expose service hello world command. In essence, this command creates a route, and I can grab the URL from the route in order to access the service. So we get the hello from OpenShift message this time. If I want to automate the generation of the route, I can just add it to my application.properties. The required property for that should be OpenShift expose. And just by adding OpenShift expose to this file, I will get for free the generation of the route. We should be able to see the route here. Here it is. Great. Let me see if I have anything else that I intended to show and forgot. No.
Well, we do have some important questions. We have a really good question from Zafar, who really wants to know, Ioannis, how does he get shell and editor set up? You got some dot files he can use to get that Emacs configuration, that shell configuration.
I think that pretty much all my configuration is available on GitHub, so I can provide a link right after.
Okay, maybe send it out on Twitter, and we'll find it, or email me, and I can get you that information. That was an important question. Now, Scott Worthington asked about, well, S2i is blocked in certain areas, so S2i cannot be used by some customers. So, what's the workaround if there's no S2i?
In the latest Quarkus release, the workaround, the only available workaround is not to use OpenShift specific resources at all, and just use the resources Kubernetes, that Quarkus Kubernetes generates. As I mentioned earlier, OpenShift is an actual Kubernetes distribution. So everything that works on Kubernetes is expected to work on OpenShift. So I could just go and deploy the resources generated from the Quarkus Kubernetes. Now, it's actually fixed in master, and if you build Quarkus from source right now, you should be able to use things like Jib and Docker with OpenShift. So it should play nicely.
Now, here's one thing I'd love to
Hopefully the next release will be soon enough.
So here's one thing I'd love for you to show me is one of the biggest challenges I have when I'm trying to manage the build my jar file, build my fat jar file, or slim jar file, then get my Docker image, my Linux container image, then get my actual YAMLs, and then get that pod deployed on Kubernetes. It's a big deal with the version number. So if I change the version string in the POM XML, will that cascade and inherit that version string all the way through the rest of those places?
Yes. You don't have to do anything yourself.
All right. And Giorgio said that that's what it was working. I was going to see, you want to test that real quick? Try the demo? I'm just
Want me to I could.
which spot?
If we have time in the end, I can add it there.
We're out of time at this point, so we do have to kind of get moving and close up, and then get ready for Josh's session in a few more minutes.
So how much time do I have left?
Zero.
Okay. I intended to demonstrate also some Knative stuff. So if we have zero time, I'll just move to the end of the presentation. What I wanted to say, and it's very important, is that everything I demonstrated right now also work out of the box with Quarkus native mode. So all commands that I used, if they are enriched with -p native flag, you will get the same experience, but for native mode, which I find really amazing, right? So let me do a quick recap. Quarkus is awesome and amazing. What we saw today is how to use Docker, Jib, and S2i extensions provided by Quarkus. We generated resources for Kubernetes, MiniCube, and didn't have time for Knative. We demonstrated how we can integrate with other Quarkus extensions, and we ran out of time. Thank you very much for having me and bearing with me. Whatever questions you might have, just shoot them on Twitter. I will gladly provide more information and help any way I can. Thanks again for having me.
Thank you so much. And I did provide Ioannis' email address on Twitter, so you guys should have that. And actually, I'll add it one more time. I'm sorry, Twitter address on the channel. There we go. Added it to the channel. So thank you so much for that, Ioannis. Awesome stuff. I really enjoyed it. There's actually several things there I had not seen myself yet. So really cool stuff there. And
I'm really glad to hear that.
Yeah. And I'm also curious. I just have one last question, and then we're way out of time. But for the native build, can that happen in cluster, or does the native build always happen on the laptop, on the client side?
The native build can happen on the laptop side or in Docker. Okay.
I was just wondering if there's a way to do that in cluster, because that actually requires a lot of resources, a lot of CPU, a lot of memory, and sometimes it'd be nice to offload that native build to the cluster itself.
I don't think that it's currently possible, but it sounds like an interesting feature to add.
Interesting idea. All right. Thank you all so much for your time today. Thank you for hanging out with us in our stream. We're going to be cutting this stream off and starting up the next stream for Josh here in a few minutes. He's going to be diving into some SRE, liability challenge. We're talking about that next. My mic still needs to permit this. I think my mic is just too hot. I tried to tune it down a little bit, but I have moved things around. That's been the problem. You can't move stuff around in this virtual world in your physical rooms. All right. Well, thank you all so much. Thank you, Ioannis. We're going to get out of here.